Today, in our notes, we're going to find something that looks similar to what we'd already been doing, but it's not the exact same. Eric, can we put the laptop away, please? Thank you. Today, we're going to be dealing with the midpoint of a segment. Again, we're on page 10. Now, midpoint. What does it sound like?
The middle point.
The middle point. That is exactly right. The midpoint is the middle point. Enough. We don't need commentary. Okay. Now, when we talk about midpoint, we're talking a little bit more specific than just in between. Right now, the way that I have drawn this picture, I have one point that is in between the other two. Specifically, if I label them, B is between A and C. Now, you can look at this picture and you could say, well, it looks like it's in the exact middle. But you do not know that in geometry unless there are markings to indicate that it is. So you need tick marks or at least measurements that tell us that B is that midpoint. But for something to be midpoint, those tick marks are necessary. So, given that J is the midpoint of the segment KL, we are going to solve for X. This same set of instructions is true for all of these, which means every single one of these is going to have a picture that looks something like this, where J is in the middle of K and L, and we have our tick marks. Once we have our picture, we label things appropriately. The first thing it mentions is JK is 3x. Is JK the left side, the right side, or all the way across? JK. There's J, there's K. It's the left side. It also mentions JL. Is that the right side or all the way across?
Right side.
Right side. Now, according to this, those things are congruent. In other words, they are the same. If I want to solve for X, and those two things are the same, what's the symbol for same other than congruent? It's the easier one. Starts with an E. Equal. 3x equal 15. Y'all know how to solve that. Divide by 3x is 5. Is that what the question asked me to solve for?
Yeah.
Yes, it said solve for x. Sweet. You all sound fantastic this morning. Same set of instructions were for B. So J is between K and L. These are congruent because it didn't actually say between, it said midpoint. JK is 3x plus 5. Is JK the left, the right, or all the way across?
It's the left side.
It is the left side. LJ is 5x minus 6. Is that the right side or all the way across? It's the right side. This problem looks very similar to the last one. It was intended that way. What do I do with these two expressions? Equal them. Because of these tick marks telling us they are the same. Now you have to be careful with this, because this picture looks kind of similar to a picture like this that we did a couple days ago. But on a question like this, I could not set them equal because there's no tick marks indicating they are the same. In fact, on this one, they wouldn't end up being the same. So make sure you're paying attention to the tick marks. I want to solve this. What am I going to start with?
Like chart.
Yes. Now, generally when we talk about like terms, we talk about things on the same side. There's none on that side, there's none on that side. But depending on who you had as a teacher, they might talk about like terms on opposite sides. But if they're on opposite sides of the equal sign, like the 3x and the 5x, how do I put them together? Got to minus one of them. Assuming they're both positive. If it was negative, how would you move it? You'd add. 5 equals 2x minus 6. Typically, once we get here, we're doing okay. Add 6. 11 equals 2x, divide by 2. And I get 5.5 for x. Yeah, I'm pausing. I went through quickly. Is x what we were trying to solve for?
Yeah.
The instruction said solve for x. What if they said find kj? Yeah, we plug 5.5 in for the x. If I said kj, I'd be plugging it into this one. If I said lj, I'd be plugging it into this one. That being said, if these two are congruent, shouldn't we get the same thing for each of these when we plug it in? Yeah. And if you're ever not sure, if you're ever like, 5.5 doesn't seem right, I think I screwed up, plugging back into both of them can be a way to check your answer. Because when I plug it back into both of them, I get the same thing, which is an indication you did things right. Now the next two look very similar, but there's a slight shift. The original picture's the same, because it's the same set of instructions. KL is 4x plus 2. Is KL the left side, the right side, or all the way across? All the way across. LJ?
Right side.
Or I guess it says JL. Right side. Now the previous two problems, we were able to set the things equal. Can I set things equal on this one? Are these the same? No. All the way across is not the same as halfway across. So I have to take a slightly different approach. Are there some things that are the same in this picture? Yeah. because we have a midpoint, the moment we see midpoint, these two things are the exact same. Which means this one right here I could have called 3x minus 7. Because these say they are the same. So those two things are equal. But setting them equal, making an equation, 3x, is it minus or plus? Minus. Minus 7 equals 3x minus 7 is not helpful. It's good to know that they're both 3x minus 7, but setting them equal is just going to get you the fact that 0 is equal to 0. Which is a true statement, but isn't telling us anything. To set the exact same things equal to one another is not going to help you. We have to approach this a different way. Do you notice in this picture that I have the left half, the right half, and all the way across? Think about what we did last week. If you have the left half and the right half, how are the left half and the right half dealing with the all the way across? How are they related? You know this. I know you know this. For the sake of argument, let's say the left half was 6. What's that mean about the right half?
That's 6.
That's 6. What's that mean about all the way across?
It's 12.
How'd you get 12?
We added them together.
You can add them together. The left half plus the right half will add up to the whole thing. And if you know left half and all the way across, you can do, it's called the segment addition postulate that we talked about last week. We can write the equation 3x minus 7 plus 3x minus 7 is equal to 4x plus 2. Part plus part equals the whole thing. I combine my like terms. The 3x and the 3x go together, giving me 6x. The negative 7 and the negative 7 go together, giving me negative 14. Do y'all trust my solving skills? Good choice. Anyway, I'm going to do ... and just tell you that x is going to be equal to 8. Because for the sake of time, I want to get to the point here. No. Okay, final problem that's on this page. And yes, we are doing the next page. I just answered that. Is this picture any different than the other pictures? In the original setup of where I put the things? No, because it's the same set of instructions. KL. First half, second half, sorry, left half, right half, or full thing?
Full thing.
K and L are on the ends. That's the full thing. JK, left half, right half, or a full thing? Full thing's already been mentioned, so probably left or right. Left. Did it actually matter if I put it on the left or on the right, though? No, because the right half is going to be the same. what would the equation look like to solve for x?
Same as the other one before it.
Kind of like the same as the other one before it. 3x plus 10 plus 3x plus 10 is equal to 80. X will be 10. There's one other key vocabulary term that we're talking about today. But for the most part, it's going to give you similar things. So once you got this down, go ahead and flip the page to page 11. Page 11 gives another definition of something that specifically goes through the midpoint of a segment. It's called a segment bisector. A segment bisector is any sort of geometric figure that goes through the midpoint of a segment. For example, right here, I've got this point P right here, which is a midpoint. How do I know it's a midpoint? It's the very middle point, and there are the tick marks. That's the key thing, is those tick marks. Now, other than the segment that has the tick marks on it, do you notice that there's a ray in this picture? That's this thing. Since it's hitting that midpoint, that is what we call the segment bisector. The ray PS is a segment bisector. The picture right next to it, here's my segment that has the tick marks, which means this is my midpoint. And going through that midpoint, not the segment, is this. That is my segment bisector. Line R is my segment bisector. So with segment bisector problems, you're going to get some problems that are similar to what we just did with midpoints. You'll get some that are slightly different, some that are slightly easier even. Like the next set of problems that say identify the figure that is the segment bisector of PQ, and then find PQ. Now remember, when it says two letters with no symbol above it, that is asking you to find the length of the segment with those letters. So, here's my segment PQ. Here are my tick marks. The segment bisector is the thing that's going through the middle, going through the midpoint. What is the midpoint of the segment PQ? M. This is the thing going through it. Is that a point, a line, a plane, a segment, or a ray? It's a ray. What's the name of the ray? MN. M is where it starts and it goes towards N. Remember, naming a ray, the first letter is its end point. It's where it starts technically. And the second letter is where it's going, and the arrow always goes to the right. So that's the identifying the segment bisector. Now it also wants us to find the length of PQ. Is PQ the left half, the right half, or the length all the way across? All the way across. The only thing we know is this part's 5.
So wouldn't it just be like 10?
So wouldn't it just be what?
10? Like, just
Yes.
add it?
Yes, because if this part's 5 and this has got a tick mark, that means this part is 5. And add those two together, 5 plus 5 is 10. PQ equals 10. Problem B. Here's my segment. What's the midpoint? M. Is there anything going through M? No. It is possible for a point to be both the segment bisector and the midpoint. If nothing is going through that middle point, then that middle point is the bisector. Sorry, I'm writing off screen. What's the length of PQ going to be? 4. Where are you getting 4 from? 2 plus 2. If that's 2, this is 2. They have tick marks, and the full length across is 2 plus 2. The last 2 problems that we're looking at today. Similar, slight difference. It still wants the segment bisector name. What is going through the middle of the segment? A point, a line, a plane, a ray, a segment. A line. What is the name of said line? Since there's only one capital letter on it, I can't do the 2-letter name. I have to find the lowercase letter by the arrow. And yes, that's N. This one wants me to find MS. MS is the length from here to here. You could do that a couple of different ways. Any thoughts on how we could start that process? Six x minus 12 is it as an expression. When I have this, I want it as a single number. But do you notice these? What do those things mean? They're equal. 6x minus 12 is equal to 15. Could I solve for x? Yes. For the sake of time, x is 4.5. Now, is that what it asked me to find? No, it asked me to find the length of MS. But I know MS is 6x minus 12, which means I can now plug x in. Now here's the thing. It's actually the hardest way to do this problem. Sometimes it's necessary to do it this way, but on this way it's harder. Here's why. Those two things mean it's the same, right? If this one's 15, what's this one?
15.
6 times 4.5 minus 12 would have given you 15. If you notice, it asks for something like this. If one of them's just another number, you know it's going to be the same thing on the other side. Could I do that on things like this one? No. On problems like this one, because neither of them is a plain number, it wouldn't work. On this one, I have to solve for x and plug it back in. Before I get there, what is the segment bisector?
Q.
Just the point Q. I still have my tick marks, so I can set things equal. How do I start solving for x when it looks like this? I have no clue what was said. I heard something was said. You can add 3. I'd get 5x equals 14 minus 2x. Combine the x's how? Adding 2x. Be careful with your positives and negatives. We would get that x is 2. The problem is asking for the length of ms. ms is the all the way across. I don't have an expression for all the way across. But do I have an expression for a half? I could plug it into one of those. Doesn't matter which one. Say I plug it into this one. 5 times 2 minus 3. I would get that this half is 7. If that half's 7, this half is 7. And ms would be 7 plus 7, which is 14. Sick of my talking? Yeah. Today is one of the longer lessons, so I understand if you're ready for me to be done. Because I'm ready for me to be done. Today is a book assignment. It's the 15th. Our homework's due on the 17th. We are on page 24 in the book, and it is problems 1 through 8. Remember, you can always grab a physical textbook